First, before we get started, we're building a 2-meter Moxon antenna today, that's it. But I want to tell you a story before we build the antenna. When I was a kid, my dad would bring me like a radio, a police scanner, and before he would even be out the door, I'd already have it disassembled because I wanted to see what was inside. I called it an engineering mindset for the non-engineer. I'm not an engineer. But also, when I was a kid, my grandfather would take me to thrift stores, and he would teach me the value of items that people didn't know had value. So today what I did is I went to a couple different thrift stores in the area, picked up a few things, and I'm going to show you how you can engineer your own 2-meter Moxon antenna from stuff you find at Goodwill. And actually, I engineered some parts in Thingiverse too, which turned out really cool. I can't wait to show you that as well. Let's get started. I know that ham radio could be very expensive, so I want to show you how to turn something like this into something like this. Now, I call it a $3 Moxon antenna, but the truth of the matter is it costs a little more than $3. We'll get into that. My intention here is to show you everything that you need to build your own 2-meter Moxon and why you might want to use things like thicker tubing as opposed to narrow tubing. We're going to go into the build, talk about it a bit, and I'll talk about some of the contacts I attempted to make while using this and how it did overall. This is something that any beginner amateur radio operator should be able to make and should only take them about a half a day if they're taking their time. When I first had the idea to build a 2-meter Moxon, I thought to myself that I would go to Salvation Army and find something relatively inexpensive. And the first thing I found was these 28-inch to 48-inch double curtain rods. And what they do is they expand out or in depending on I guess what length you want. And my thought was if I cut these right, I would be able to expand them both horizontally and vertically depending on how the orientation of the antenna was, which would allow me to make maybe a 6-meter and a 2-meter adjustable Moxon all in one. Long story short, the problem with these curtain rods is they're very sensitive and I could bend them with my hands. And if you were maybe using these for home use, it would be fine. But if you're going outdoors, maybe you need something a little more rugged. That's when I went to Savers, which is another thrift store around here, and I found these awesome stools for camping. So here's what I did. I ended up taking these, and the first thing I did is I decided I wanted a 2-meter Moxon. So I needed to get the dimension for a 2-meter Moxon, which I have linked below. Once I measured each one of these 2 legs, or these 2 parts, and I confirmed that they were going to be long enough for a 2-meter Moxon, I then went to work by removing the rivets here and here. To actually remove these rivets, there was a couple of suggestions online and some of them didn't work for me. One was to use kind of like an ice pick with a hammer and tap into the rivet on each side or on each leg. And what that would do is eventually bend and break the rivets and they would come out on each side. That didn't work, like I said. Ultimately, I did try a needle nose plier and the needle nose plier didn't work. So I ended up using my Ryobi grinder, and I was able to kind of basically just grind these right off, one on each side. And once these came off, these little bolts that go through both legs came off, popped off, and then I was able to get this top green cloth for the stool off as well. So I then had 2, we'll call them U-shaped pieces for what's going to be our 2 Moxon build. Now, I wanted to be done with this right away, so after I cut the rivets, I just started cutting until I found an ideal length. You're going to have 2 sides of the Moxon. You're going to have the driven element and a reflective element, or reflector element, excuse me. And the problem with that is both of those elements actually need to be a total length on the long side of 28.2 inches, okay? And no matter which way you measure it, and even if your girlfriend measures it, this is not going to be 28.2 inches. Additionally, on one side you need another 3.12 inches, and on the other side another 5 inches.
Hi, future me. Those measurements are very important, and we're going to talk about them in just a little bit here. So stay tuned.
Because the driven element is actually made up of 2 parts, the side angle and we're going to call it the long side. And to do that, you need to start thinking kind of, well, what do I do? Well, 1 corner, 2 corner, 3 corner, 4 corner. So you know that you have the 4 corners. It's just you need to do 14.2 inches here and then 3 inches here for the driven element. Where do you start measuring when it's rounded like this? Well, all I did is I made like a 90-degree angle like this before I cut, and I measured from that 90-degree angle, and then I measured down. I'd rather be long as well, so maybe I go to 14.8 inches. I'd rather be long as opposed to short, because then I could always cut down, whereas if I have to add on some kind of aluminum, it's going to be more difficult. I hope that makes sense. But for the reflector element, it needs to be 28.2 inches, and again, you don't have 28.2 inches, so you are going to have to add some kind of metal substance to that. I found the perfect solution. I had a piece of a broomstick that I used on another Yagi I built about 1.5 years ago, and there was some extra portion of that broomstick left over, so I used it because it's aluminum or some kind of metal, and it just so happens that it fits inside the inner diameter of the 1-inch lawn chair, whatever we're going to call it, fairly well. So I placed it in there, and I cut this long, or I kept it long, because as it goes down, it actually gets tight, and it holds pretty well on its own, and I just did that on both sides. So again, we wanted to have about, I think it was 28.2 inches there, and if I ever needed to, I could adjust it out slightly until I find that sweet spot, which for me happens to be right here. So this is the reflector element of our Moxon. And then this is going to be the driven element, but the problem is then, okay, you just have 4 pieces, and how do you, I mean, it's not done yet, right? So initially what I ended up doing is I took some pieces of PVC, and these are 1/2-inch PVC, and they fit okay into each end of the 1-inch tubing, and they're non-conductive, so now we still have our 2 separate sides of the Moxon, right? And the cool thing about this is these also kind of go into place, and they kind of hold in there pretty well. That's what I did there, there, and there. Now we're starting to get a Moxon. You see this? And again, if I need to, I could adjust this in or out as I'm kind of playing with everything. Well, what do you do in the middle here? This is your feed point. A couple things you could do with the feed point, and kind of how I initially did it was, again, I just took a piece of PVC and I put it in here. In order to put it in on both sides, maybe you got to take part of this out and then bring this in. It takes a little bit of playing with, but basically eventually you'll get all the sides in. And then that kind of gave me something that's, you know, kind of looked like a Moxon and being held up everywhere. But then I realized that there's going to be a problem where, I mean, how am I going to attach a piece of pipe or tubing to this? So I designed something that I think is really cool. I designed these. These are designed in Tinkercad and printed with PETG filament. I use PETG filament because it's pretty good with ultraviolet light, and it's kind of made for outdoor use. And the whole concept of this was, you know, maybe I do keep the PVC pipe in here, but then I have these to sit on, okay? And then screws come through, because then it really holds everything together, but also then I could take a piece of PVC and have it go here, so I could use this as a handheld Yagi, or Moxon rather, excuse me. The problem with that was it worked really well, except if I wanted to have this in a vertical position while on a pole, it wasn't going to work here. So I need to also print them for this side as well, which I just finished and took about 11 hours on the printer. Another thing that I probably should have done, I didn't because I don't have the right tools, but if I had a drill press, I probably could have drawn a line here with the drill so that I could have adjusted this on the go, whereas now these are set holes that I drilled, 3 on each side for my little spacers to go. It would be nice if I had the ability anywhere I needed to say, oh, okay, that lines up right there, and screw them into place. Doesn't matter, it's good to go. Because it could disassemble, and I have these screws and I now have these spacers, I could fit this in a backpack and I can go be portable, you know, I could be pedestrian mobile if I wanted to. All right, so 2.5 inches on each side. We'll say roughly right about there. I'm not completely measured. Now I've already drilled 3 holes on each side, which basically I use this as a template and put this on top, drill down, down, down. Again, it would be better if I had a drill press, but I don't, so I just used a hand drill. And yeah, the holes are crooked, I could tell, but sometimes that's life, you know? So we're just gonna go ahead now and we're gonna basically place these into position where we're going to want them. And real quick, because I printed this with support, I got to remove all this stuff right here. Now, once you kind of get things into place here, it's difficult because you might actually have to recut things depending on if you're too long, you're going to have to cut it down. And that's also, again, why I say maybe it would be better to make a groove in here, a line, if you had a drill press and you can go to the side. But I don't. So I've already kind of measured this out and I've cut it. But here I am in position, and to make sure I'm in a good position before I typically drill the holes, which again are already drilled, I'm going to get a piece of PVC pipe and I'm going to lay it here. Basically just taking this piece of PVC here and kind of making sure that they're equal lengths from here to here and here to here, and it looks okay. That's what I decided to do. And now I'm going to go ahead and I'm going to add the number 10 bolts and nuts. I'm going to go ahead and actually repeat that on this side as well. And again, 2.5 inches or so, 2.5 inches. Now you can mark these, and I think that's a good idea to mark them, because then when you're ready to go take this portable and you take it out of your backpack, it's all marked and all you got to do is hit it to that point. You know, maybe draw an R on here or whatever, so you know that this is the reflector and this is the director. And as I'm installing these spacers, as I'll call them, I don't tighten down the wing nut, which I use because it's easy to connect and disconnect. I don't tighten it down all the way immediately, because that gives me room to move this around and find and kind of get everything fit through. And perhaps these brackets are the coolest part of this whole thing, because really we could scale down the brackets and you could use this for 1/2 inch, you could use this for 1/4 inch, 1/8 inch, whatever you want. It's something that would work for Yagis too. Huh, B. I love engineering, it's so fun. But let me go ahead and also put on this piece of PVC. 3/4 inch will fit on there just fine. And then after I line it up where I want it to, I'll drill the holes through here. And I just wrapped it a few times as like an air choke. I don't know that it's going to make a huge difference. And I have these ring connectors here. One will go on the shield portion or one side of the Moxon, and one will go on the other here. Let me show you. Okay, there's this thing that we kind of need to talk about real quick. And again, we have this Moxon antenna. We have 2 portions of it. The side that we're going to be working on now is going to be separated by PVC, or basically they're not going to be connecting. And that's going to be where we're going to put our shield and our center conductor of the coax. The other side, again, being the reflector. And when we want to put this on with our piece of PVC pipe, well, a couple of things. We want to make sure that our director is in the front and our reflector is in the back. If we do it like that, whatever way we point is the way that we want the signal to go. However, if we have this backwards and we point it, everywhere we point, we're going to be working off, we'll call it the back side of the Moxon. I almost called it a beam, the back side of the beam. So take that into consideration. We're going to go ahead and we're going to put the director in front. I have the air choke here. Hi, ham radio dude here, and it's the next day. Kind of slept here on the garage floor thinking about this, but we do have something we need to talk about this Moxon. And you know, I got the spacers on, and it's actually starting to look like a Moxon, except it's not, and it doesn't perform like a Moxon. Why is that? Well, remember earlier I said we always want to leave things longer, we can cut short. I cut short, and I thought I had the measurements pretty good, but let's go ahead and confirm those measurements and actually just kind of talk about them now. And I think it's important that I leave this in here, because even though my standing wave ratio looks really good, my impedance values are way off. Like, you're talking 24 impedance, where it should be close to 50 ohms. And it has to do, I think, with the measurements. And if I'm having these issues, somebody else is having these issues. So let's talk about our issues. Right here, I have a list of measurements. Okay, A is the length of the driven element and the reflector. And A needs to be 28.2 inches, okay? I'm just gonna write that, 28.2. And what our A actually is, I'm going outside of the driven element to outside, is 30.1 inches. So we have 30.1 inches. First of all, that's gonna be too long, right? The second thing we need to know is the distance between the reflector and the driven element. That needs to be a spacing of what I said earlier, 2.1 inches. However, There also needs to be a total length between the two of what would be something along the lines of 11.5 inches outside of the driven element to the outside of the reflector element. I'm at 14 and a half. So let me write that down real quick. 11.05 equals 14.5. I think you see where this is going here. I need to make sure that I tighten everything up because all these things like the spacing of the elements, they could actually have an effect on your impedance value and your overall, actually your direction as well. So this might not be as directional of an antenna if you don't have the measurements correct, is what I'm trying to say. Okay, and let's see here. So B is going to be the little part here, which is on the driven element on the side, and it's supposed to be about 3.17 inches. That's pretty close. I'm not going to touch that, I don't think. And it's the same for this side too. Yeah. But D needs to be 5.76 inches. Okay, and what are we looking at? Whoa. 7.5 inches. I'm going to go do the math real quick to see how much I need to take off of each portion of this antenna and if the math adds up. I'm going to double check that and then cut it so we don't mess this up and not have an antenna for a video that's supposed to come out in 3 hours. All right, so it's a little bit shorter. You might not be able to tell, but we still have more problems. And this is good. This is really good. The website that I've been using, antennatop.org, I think it was, it says 28 inches for 2 meters with 1 inch tubing. I went to a few other websites that calculate your length, and for 146 megahertz, it says, oh, you need 27 inches at 1 inch of wire. Now this is tubing, and I'm sure that the velocity factor is probably having something to do with it all too. But I'm now at 122 megahertz with a 1.2 to 1 standing wave ratio and an impedance of 55 ohms. So we're starting to see stuff, but it's still not there. I need to go shorter on this. And I'm going to take about a half an inch off of each side of the driven element and then a half an inch off of the reflector. We'll see how this works out. I'm starting to get worried because I don't want to cut too short, but at this point, I think that's what I have to do. Okay, so actually we're done. We got the measurements all good. A couple things I want to note here as I put on these gloves. First off, the coax connector that I have here, it's fine, whatever, but I want to go ahead and make this a lot neater. So in the future, I'm going to get a better piece of coax. This is actually RG58, and we'll make these connectors a little bit better. I got a lot of extra holes in here because of the cutting I had to do, but hey, if you're new, I guess that's a good point, is measure twice, 3 times, cut as many times as you want as long as you're cutting short, but not too short, right? I guess my point there is be patient. These things do take time, and you know, maybe it doesn't turn out perfect the first time, but I'm glad I got another stool. I'm going to try again, and I'm going to try some different stuff. I think next time I'll do a Yagi, or maybe like a Halo. The impedance values, I just want to kind of remind you that the impedance values might be way low or way high, depending on the spacing of your reflector and your director. So that was pretty interesting stuff. And now you're probably wondering what I'm doing. Well, this is SWR oil, and it really just helps you get SWR, but it gives you more gain as well. So it's kind of nice. You put this on here, and then all of a sudden you're talking around the world in minutes. I'm kidding. This is Neverdol. It's going to shine the aluminum because, you know, hey, if we worked hard on this project, even if it didn't turn out exactly how we want it, why not make it look good? And I guess you're wondering, how does this perform? Well, I went to Illinois Beach State Park. I used FT8, and I was heard with 5 watts. I was heard in Peoria, Illinois. I put it on the map, but that's a pretty good distance. It's nearly across the state. I made a couple contacts locally as well.
Let's wrap it up by talking about how cool or why I like the Moxon. And I know you could use a 3-element Yagi. We'll do that later. This is a 162.450. It's NOAA weather radio, Racine, Illinois, or Wisconsin, probably about 35 miles away.
It was cloudy and 72. And Duluth, it was partly.
Yeah, you get the point. There's some static in the line, right? Not a huge deal, but what if you were trying to enjoy NOAA weather radio? What happens if I take the Moxon in a vertical or near vertical position and I point it that way? What if I point it away?
Showers and thunderstorms likely through the day.
When we change to the side of the beam, we're going to lose a little bit or a lot. We're getting most of our gain off the front side and the back side of our, I say beam, but our Moxon. But also, what happens if, now FM is usually vertically polarized, and that's why I'm vertical right now, but what happens if I go horizontal, called cross polarization?
In the late morning and afternoon. Patchy fog in the afternoon. Waves 1 to 3.
Yeah, it lost the signal like crazy, right? Because every time you go from a horizontal to a vertical, the other person stays as they were. That's like a 20 dB gain of loss or something along those lines. That could actually be used in your favor if you're doing direction finding, though. So think about those things, and that's kind of why I build the Moxon. It's lightweight, it's portable, I can go vertical or horizontal, and it's good for direction finding. We're going to do a part 2. We're going to look at and see if we can discover a little bit more of the actual, how is this antenna performing front to back ratio and everything along those lines. We'll have probably a bunch more, so leave your comments below, and we have a couple other videos we're going to finish up. You guys know how this goes. I had fun doing this video, but more importantly, it was an educational thing for me, and I hope it helped you learn 1 or 2 things about building an antenna. Anybody could do it, essentially, right? Wait. I forgot there was one more thing. Remember in the beginning of the episode, I talked about my grandfather, my father. First of all, I understand now why Dad doesn't want me taking things apart, because I can't get them back together and looking good or working correctly most of the time. So point taken, Dad. And then in Grandpa's defense, he's rolling over in his grave right now because he would be saying, son, those chairs were vintage, made in Costa Rica, and they're worth a good penny each, and you could have sold them both and bought your own Moxon. And he's right about that. But what I would say is knowledge is more valuable than anything. So thank you guys for teaching me that and not getting down on me too hard for taking things apart when I was a kid. Bye.